Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P006A indicates a MAF, mass airflow, sensor circuit range or performance problem specifically in Honda Civic models from 2016 to 2021. The MAF sensor is crucial as it measures the amount of air entering the engine, allowing the engine control unit to optimize fuel delivery for efficient combustion. If this sensor misreads or fails, it can lead to various performance issues. In this particular case, you may also see associated codes such as P2228 or P2229, which need to be addressed prior to focusing on the P006A. Always begin troubleshooting with a thorough inspection of the related systems, ensuring that all components are functioning correctly before diving into more detailed diagnostics. The MAF sensor, positioned between the air cleaner and throttle body, measures the volume of air entering the engine. Its role is critical because it informs the engine control module on how much fuel to inject, impacting engine performance and emissions. If the MAF sensor has a performance issue, it may not read the air intake accurately, leading to incorrect fuel delivery. Along with the MAF sensor, components like the PCV, positive crankcase ventilation valve, air cleaner, and intake air duct are also involved in maintaining proper airflow to the engine. Problems in any of these parts could contribute to the DTC P006A. Therefore, understanding the exact location and role of each component is vital for effective troubleshooting. The possible causes of DTC P006A include poor electrical connections that may disrupt the signal from the MAF sensor to the engine control module. Any damage to the MAF sensor or related components, including the wiring harness, can also be the source of this issue. Additionally, blockages in the air intake system, such as a dirty or clogged air cleaner element, can prevent proper airflow, disrupting the performance of the MAF sensor. Identifying these issues early on can streamline the troubleshooting process, ensuring that appropriate measures are taken to restore functionality to the engine management system. Symptoms of DTC P006A typically manifest as poor engine performance, which may include rough idling, poor acceleration, or stalling under certain conditions. A malfunctioning MAF sensor can cause these performance issues by providing inaccurate data to the engine control module. Additionally, the check engine light will likely illuminate, alerting the driver to the issue at hand. In some cases, drivers might notice irregular engine idling, where the RPM fluctuates unexpectedly. Recognizing these symptoms can help diagnose the problem before it escalates into a more significant issue that might affect vehicle safety or drivability. In the first troubleshooting step for DTC P006A, start by conducting a detailed parts condition check. Inspect the MAF sensor, PCV valve, hose, and other related components for any signs of damage or poor electrical connections. Pay special attention to areas where wear and tear, moisture, or exposure to heat might have caused issues. If you find any damaged parts or loose connections, replace or repair them as needed. If everything appears intact and operational, proceed to the next troubleshooting step. Addressing these foundational issues is crucial, as they can have a cascading effect on the performance of the MAF sensor. The second step involves a visual check of the intake air duct. Begin by examining the duct for any signs of damage, such as cracks or holes, which could allow unmeasured air to enter the intake system. Additionally, assess whether the duct is secured properly. A loose duct can disrupt airflow readings. Any irregularities identified should be addressed immediately by either reconnecting or replacing the intake air duct as necessary. This component plays a pivotal role in ensuring a consistent air supply to the engine, making it crucial for the accurate operation of the MAF sensor and overall engine performance. In this third step, focus on the air cleaner element. Check for dirt and debris accumulation, as this can significantly impact airflow into the engine. A dirty or clogged air cleaner element restricts airflow, leading to skewed readings from the MAF sensor. If dirt is found, it is essential to replace the air cleaner element promptly to ensure an unrestricted air supply to the engine. Failing to address this issue can compound the performance problems indicated by DTC P006A. Fresh air is vital for engine efficiency and longevity, making this step an important aspect of engine maintenance. The fourth step requires checking the MAS sensor signal without the engine running. First, turn the vehicle to the off lock mode, then switch to the on mode without starting the engine. Utilize the HDS Honda Diagnostics system to assess real-time values of the MAF sensor. The expected output should be approximately 0.2 grams per second, G second. If the current conditions match this threshold, proceed to the next step. However, if the values differ, consider replacing the MAF sensor or the IAT intake air temperature sensor 1, as problems in these sensors can lead to inaccurate air measurement, thereby triggering the P006A code. In the fifth troubleshooting step, start the engine and maintain the RPM between 2,000 and 3,000. This variation is critical as it simulates various load conditions on the engine. Using the HDS, monitor the data list for MAF sensor readings. The readings should change as you manipulate the throttle. If they do not, this suggests that the MAF sensor might be malfunctioning. In such a case, you may need to replace the MAF sensor or the IAT sensor 1 to resolve the issue. Accurate readings are vital for engine performance, and discrepancies imply underlying issues that must be addressed. The final troubleshooting step involves holding the engine speed at 3,000 RPM without any load, while keeping an eye on the various parameters via the HDS. Ensure the vehicle is in park or neutral, so the transmission does not engage. Allow the radiator fan to activate, then let the vehicle idle. Take note of the recorded parameters: engine speed, vehicle speed, MAP, manifold absolute pressure sensor, and TP, throttle position sensor readings. Check the OBD, onboard diagnostics, status for DTC P006A. If it shows as failed, replacing the MAF sensor or IAT sensor 1 is necessary. However, if the status indicates passed, consider checking for loose terminals or other connection issues, and try to replicate the failure by monitoring similar driving conditions. Once all necessary repairs or replacements have been completed, it's crucial to perform a final verification to ensure everything is functioning correctly. Begin by confirming that all replaced or repaired components are properly installed and functional. Next, recheck the vehicle for any remaining DTCs to ensure no other codes have emerged. Clear all existing codes and take the vehicle for a short test drive to observe its performance under normal driving conditions. If everything operates smoothly without re-triggering the P006A code, the repair can be deemed successfully completed. Final verification ensures that the problem has been fully resolved and the vehicle is safe for daily use. Preventive maintenance is key in avoiding future occurrences of DTC P006A. Regularly inspect the air filters to ensure they are clean and unrestricted, as a dirty air cleaner can cause significant performance problems. Schedule timely maintenance checks to catch any sensor or connection issues before they escalate. Keep an eye on the MAF sensor and its wiring. Regular inspections can help detect potential problems early. Additionally, Check other related components like the PCV valve and intake hoses to ensure they are in good condition. By investing in preventive maintenance, you bolster the longevity and reliability of your Honda Civic. In summary, DTC P006A signifies a problem with the MAF sensor circuit or its performance, which can translate to serious issues if not addressed. Understanding the critical role of the MAF sensor in maintaining optimal engine performance is essential. By following a systematic troubleshooting approach, including checking connections, inspecting components, and verifying sensor functionality, you can effectively identify and solve the issue at hand. Regular maintenance, including inspections of air filters and sensors, is vital to prevent similar problems in the future. A proactive approach ensures a reliable and efficient driving experience with your Honda Civic. Please like and subscribe to the channel. See you next time.